All right, welcome back. Chapter 17, Part 3. Now we're going to talk about two types. So, now that we know what glaciers are, let's kind of look at two types. First of all, know that glaciers are everywhere. There's glaciers in North America, South America. There's even glaciers in Africa. Very few, but there are. The only place we don't see glaciers is Australia, and that's only because Australia either is too warm and its mountains aren't high enough to be that cold. But when we look at glaciers around the world, there are two types. We've been talking a little bit about alpine glaciers, mountain glaciers, but the other type are ice sheets. Now, mountain glaciers occur wherever there are mountainous areas it's cold enough to happen, but ice sheets only happen in Greenland and Antarctica. So when we look at alpine glaciers, right, alpine glaciers form in several ways, but the first one here is the Cirque Glacier. So this little area here in the mountains, surrounded by the mountains, kind of like a bowl-shaped depression. The snow falls here every year, never melts. It forms a Cirque Glacier, kind of in this hollow. And you'll see right here, it's kind of coming out. When a glacier finally gets large enough, starts coming down the mountain, it usually follows the easiest way out, like a valley. It becomes a valley glacier. So right here is the Cirque Glacier. Now it's in the valley. When a glacier comes down out of the mountains, if it makes it all the way down to the base of the mountains where it's regular forest, not mountain anymore, they call that a piedmont. Kind of spreads out. Now, in some mountains, it's so cold and there's so much of this ice, they actually form several connected glaciers. They call that an ice cap. It actually covers several. Now, ice caps are very large. They're basically the same as an ice sheet except for size. So as we talk about, they're less than 20,000 miles. But if they were more than 20,000 miles, they'd be ice sheets. Huge, large areas of ice that cover almost an entire continent. The only two left in the world right now are Greenland and Antarctica. To give you an idea how big this is, Greenland is roughly the size of Mexico when it comes to square miles. And almost the entire island is one big thick 1.5 to 2 mile sheet of ice. And Antarctica is about the same size as the United States, almost entirely covered in ice. So here's an example. I know my picture had kind of some of it, but here you have that ice sheet, the large central ice sheet. You can have valley glaciers. They call them here outlet glaciers, just the same. If the glacier gets all the way down, and many of them do in these two areas to the edge, right, they can actually have an edge that's over the water and parts of the iceberg break off, and that's where icebergs come from. So an iceberg is really nothing more than a big chunk of ice that broke off from a glacier. And what happens is this, is that when glaciers get down from the ice cap to the coast, to the ocean shoreline, they kind of go out, a little bit of them stick out over the water. And they do, because ice floats, they float a little bit. But over time, the further out it gets, out into the ocean, and eventually the tips break off, and that's where icebergs happen. So the iceberg that sank the Titanic actually broke off of the ice sheet from Greenland. So these type of glaciers, by the way, a fancy term for those are tidewater glaciers. All that means is that the edge of the glacier hits the ocean. So the next part is erosion. So I've been talking a little bit about how glaciers moved sand, dust, dirt, rock, debris. And ice doesn't sound like it, but it actually is one of the strongest forces. It works because, one, glaciers weigh so much, and it works because they are constantly working. Glaciers move slowly an inch a day, every day, for years and years and years with a ton of force. And they can grind down even the hardest rock and create some really interesting forms. The Great Lakes, Lake Michigan, Lake Superior, were carved during the last ice age 20 years ago. So two ways this happens: plucking and abrasion. Plucking is where a glacier is coming down a valley or moving across a plain, and if there's a piece of rock sticking up, it kind of snaps it off and brings it with it. It's been plucked. Now, it does this. It plucks rocks up, it picks up dirt underneath it, under sand as it grinds over the dirt, and all this material in the ice. It's like a dirty snowball. And as they grind against each other, they call that abrasion. So the rocks hitting each other, and they kind of snap each other off, and they can even grind it down into what they call glacial flour. Okay? So how does this look like? Well, one thing is, it can literally, just like if you were to, take your fingers in the sand and go like this, you leave scratch marks. it can leave scratch marks in solid granite. Glacial striations. The rocks that are inside the glacier, as they get pushed around and moved around, can bump and grind each other until they are smooth and shiny, called glacial polish. And the last thing is, it can grind some rocks into dust. Just literally break them down into basically dust or sand, and that's called glacial flour. So here in Central Park, New York, this sheet of bedrock at one point was under a glacier as it went over, and you can see the carvings just cut into it right there. This lake in Canada is at the base of a glacier. As the glacier gets down to the lake and melts, all that ground up dirt and dust called glacial flour is put into the water like sediment. It's so fine that it actually kind of makes the water turn this really bright blue because it reflects blue wavelengths the best. And even though it's ice, we still have streams, okay, inside the ice. So sometimes on top of the ice, sometimes in the ice, it melts. So glaciers move downhill, usually. It's just like water. And they're like conveyor belts. Anything that gets in them, like rock or dirt, goes with it. And so that is moved. And when that material gets to the end of the glacier, or the glacier melts, it doesn't bring it back with it. It just dumps it. So I've always noticed, you see these big, huge snowdrifts, on the city in the winter. And as they melt, all the sand and dust and dirt or garbage in them is just left there. Okay? And so what happens is when a glacier leaves behind sediment, dirt, and rocks, it's called a moraine. Inside the glacier and on top of it, especially in summer, some of the ice melts. So if you have a puddle of ice or a little bit of water on top of the glacier, that's a supraglacial stream. And if it's inside the glacier, it is a subglacial stream. And they can also move sediment. So here's a picture right here. These are two glaciers. They're coming down the valley right here. So you can kind of see the dust and dirt. And on the sides are these kind of ridges of the material they've left behind. And these are moraines. Here's what they look like. Here is a supraglacial stream. In the summer, the top of the glacier melts a little bit. You get these kind of rivers of water here in Greenland. And sometimes they actually melt down into the glacier and form these ice caves. And here you can see a little stream flowing through and all the rocks and dirt and sediment that it moves. We often see the sediment is left behind. At the edge of a glacier, when the water comes out and the glacier melts, it leaves behind this big, huge, just basically a layer of sediment. And it's called a glacial outwash plain. Now, one thing that happens is there's so much stuff inside the glacier, it is really the ultimate dirty snowball, that the streams that come out are often braided, and they form these pro-glacial lakes. You can see this right here. Here's a glacier coming down from the mountains. It hits the ocean, and this water right here, it melts, but there's so much sediment and so much dirt that it basically formed a little sandbar right in front of it. Now, some of the erosional things we see, I talked about a cirque glacier. Let me show you this. Let me come back to the tarn. Here is a cirque, the kind of circular area between the mountains where the snow forms, right? So the snow falls and it's basically this bowl. But this area here is called a cirque, and it's what holds the Cirque Glacier. In between are these ridges, the headwalls. You can see here this glacier, it forms right here, it melts. When it melts, it forms what's called a tarn. So this area here is kind of a cirque that doesn't have ice in it. It's too warm. If it was colder, that would also be a glacier. I'm going to come back to these terms, arete, col, and horn. This is kind of what they look like. Here's a glacier in the mountains right here in the Himalayas, right? A col is just kind of a narrow valley between glaciers. And then the head walls are the aretes. The glaciers just kind of carve these walls. If the glaciers carve all sides of a mountain, you get this kind of sharp peak called a horn. And that's because glacial ice has literally carved away all the rock on the side. Now, glacial valleys are unique. We can tell areas that used to have glaciers. This right here is Yosemite National Park. Remember we talked about water. Water generally forms V-shaped valleys. So when we find a valley that's kind of U-shaped, we can tell that was a glacial valley at one point. Because in Yosemite there's a stream but streams don't carve U-shaped valleys. So this at one point there was a glacier here thousands of years ago. Now, we can also see a hanging valley. So you'll notice there's a small kind of U-shaped valley right here, and then it ends in this big glacial valley. But the floor of this valley is much higher, and a waterfall comes out. And let's look at that close up. Here it is right here. What happens is, this was a glacier that met this bigger glacier right here. But because glaciers don't carve like water, it carved a U-shaped hanging valley. In glacial valleys, we often see these string of lakes. So this is a U-shaped glacial valley. And if you look at a map of it, you see almost like a necklace of blue dots, these lakes. But each lake is a little bit higher up. They call these paternoster lakes. And then the last one I think is neat, the Roche Montagne. And this is basically a mountain or a hill that has been stripped clean. A glacier at one point was coming down this valley. This mountain may have been much taller. It literally just ground off the top of it right here. Almost like it just went right over it. And if you've ever heard of a fjord is a glacial valley, again that U-shaped valley, but here it's near the ocean, so the bottom of it is flooded. So this right here is in Norway. You can see all these little lines on Norway. These are actually fjords. Some of these valleys can be 30 or 40 miles long into the interior of the country, and the walls can be almost a mile from the top down to the bottom. You see fjords in a lot of northern climates. So in Norway, you see them in Scandinavia, you see them in North America. Areas that are cold and maybe don't have glaciers now, but may have in the past. You will not see fjords in Africa. Where Africa is located, even though plate tectonics has moved it, Africa has always been in the tropics. So they've never had glaciers to form fjords. And that kind of is my next part. When we see glaciers and glacial land forms, well, if we see glaciers, we know that that place is currently cold enough to be glacial, that it's cold year-round. But what if we find glacial landforms south, like Chicago? Well, that tells us that at one point, Chicago was cold enough to have ice year-round. And so that's kind of how we look at the past. So climate. And climate can tell us things, and glaciers can tell us things about how climate has changed. So example, here's a pre-glacial landform, before glaciers, maybe 40,000 years ago. You've got a normal V-shaped valley with rounded ridges. But now it's cold. So 40,000 years ago it was warm, but 20,000 years ago it got cold. And now glaciers form. And we start seeing all these glacial landforms. The ice carves this landscape into this. But then 10,000 years ago the ice melts and leaves behind this. We see glacial valleys, paternoster lakes, cirques and hanging valleys. And what that tells us is, even though it may be very warm now, like California, at one point it was glacial. Alright, we've made it through yet another section. I'm going to pause right here, and when we come back, we will be doing section 4.